So what we have here are the three main notes that we're going to take today. Now, we're going to include some examples in here. So leave a little room between each line. That way we can go ahead and show some examples. We've got plenty. Hey, Galaxy, make sure you keep yourself muted, please. So go ahead and copy that down. I'm going to grab this link, give it to some folks real quick because got to make sure my people are taken care of and we're good. All right, and boom. All right. And boom, last person done. All right, let's go ahead and get to it, my party people. So 3 things we need to know, gang. 3 main things we need to know. 1, what are like terms? That's the first and foremost thing we need to take care of here. And so like terms are basically just terms that have the same letter and the same exponent. You're going to see that it's called the same variable right up there. But if it has the same letter and the same number up top, they are like terms. So first and foremost, you got to know how to identify them. So let's play a little game real quick. I'm going to write something out, 2 terms, and as quickly as you can in the chat box, because I had to mute you guys, in the chat box, let me know yes or no if these would be considered like terms. So again, they have to have the same letter and same power, same exponent. So here we go. Yes, no, yes, no. Are these like terms? Let's have a little warm up here, man. Let's go. Yes or no. Don't look at other people's answers. Go ahead. Give it your best go. Yes or no. All right. So let's go ahead and identify some of these components real quick so we can really, really feel more confident about this. So same variable means the same letter. And that's going to be the x there. Yeah, we're good. X and x. Now, when we say the same exponent, the exponent is not the number in front. No, it's this right here. And so when you check that out, those are absolutely different. Those are absolutely different because one of them has a 2 and the other one has a blank. Now, remind me real quick, everybody. What exponent is there if there's not one written? Hey, shout out Tiff, being quick there. Yeah, it's going to be 1. So again, if you don't see an exponent on a number or a variable, the exponent is always 1. All right, always 1. So you can treat that as a 1 right there. All right, so let's go ahead and try again then. So let me move these to the side. Let's go and try another pair here. Let's go ahead and say we've got yes or no. Go ahead, 5, 4, 3, 2, and 1. Cool. For the most part, we got it right. Yep, exactly. Again, they have the same variable over here. And those variables have the same exponents. So again, this is what makes them like terms. Having the same letter and the same exponent right there. All right. So let's go ahead and have a little challenge part real quick. What if we had, let's go ahead and say this. What if we had 12x squared y and let's just go ahead and say 21xy squared. Are those going to be like terms? Yes or no? Are those going to be like terms? Where is it? Yes, there you go. Are those going to be like terms? Let's find out. Let's find out. So do they have the same variables, everybody? Yes or no? And it's cool to say if you're not sure, for sure. Yeah, it's absolutely fine to say that you're not sure. So let's zoom in a little bit. If we're taking a look at these, we've got, okay, 12x squared and y, 21xy squared. So we got the same variables. I don't think that's an issue. But what's the problem? The problem is the exponent of 2 is with the x here. The exponent of 2 is with the y over here. So technically, these have different exponents. So they are not going to be like terms. So long story short, just to recap here, there is a difference between x squared y and xy squared. They are different. They are not like terms. So are not like terms. All right, because that's one of the most common mistakes that a lot of people make in the beginning. So I think that's, it's really worth just talking about this over here for just a few seconds, just because it's very easy to kind of wander away from the truth there. So go ahead. It's always XY also. Yeah, that's right. So in the chat box, let me know. Have you ever, either rushed a problem or gotten confused by something like this, believing that they were like terms? Sweet. So anybody here who's feeling apprehensive, feeling anxious about the math, look at the chat box. We're all here in the same position, trying to grow. So just make sure that what you're trying to do is get better and not try to look right. We're trying to be right, and that's going to take making mistakes. So keep that in mind. Exactly. Be wrong here, so you're not wrong on the test. So now let's talk about adding and subtracting like terms here. So briefly here, let's go ahead and put some like terms in front of us here. So let's go ahead and say we've got, 5x plus 2x. Everybody, what does that become? 5x plus 2x is what? So I see some differing answers in the beginning there. I see some people saying 7x. I see some people saying 7x squared. Ah, okay. Hey, Galaxy, go ahead and type your question out. I got you. So yeah, what's the difference? 7x or 7x squared, what are they going to be? Think about it like this. When you're adding and subtracting things, you're basically saying, hey, I've got 5 x's, and let's say my buddy has 2 x's. When we add these x's together, how many of these x's do we have? 7 of them. 7 x's. Not 7x squared, just 7 x's. And so remember, the rules here are, we're going to go ahead. Yeah, exactly. You're only adding the exponents of multiplication, Ashley. Exactly. And so here, you add and subtract the coefficients. So the 5 and the 2 become 7. You leave the variable the same, because what you're saying is you're adding and subtracting the amounts of that variable. So if I have 2x plus 10x, 2 of them and 10 of them together is 12 of them. And you're not touching that variable, just 12x. So does that help anybody understand that a little better? Go ahead and hit me up right there in the chat. Let's try another one out real quick before we continue. Here's another one. Let's go ahead and say we got, let's go ahead and use 19x minus 13x. So what we're saying here is we have 19 of these x's. Let's take away 13 of these x's. How many of them would we have left? That's right. We would have 6 of those x's left over. Exactly. Just like that. Just like that. Now, let's try this one quick here. What if we were trying to add these terms together? What if we had, let's go ahead and say 25y plus, let's go ahead and just say 7 of those y squared. What would that be? Quick, go. What would that be? What would that be? What would that be? What would that be? Nobody has an answer? Come on, guys, hurry up. What's the answer going to be? What's the answer going to be? I like it. So take a pause for a second. Take a look at some of these answers here in the chat box. We've had a couple of people say already, hey, 32y squared, 32y squared, 32y squared. I think someone wrote 32y, 32y cubed. But then I have a few people here saying nothing. You can't add these. Everybody, why can't I add these? Why can't we add these? They're different. They're not like terms. Remember, guys, we're taking a look here. Remember, like terms that have the same variable, so the same letter, right? And they also have the same exponent. When you take a look at 25y and 7y squared, we absolutely do have that same variable. We do. We do. But do we have the same exponent? We do not. Nothing there, a 2 there. And so because of that, these are not like terms. We cannot add these. We would just leave it the same. And so if we're asked to add something like that, the simplified result would just be 25y plus 7y squared. So yes or no, my party people, does that make sense? Hit me in the chat box here. Does that make a little more sense in terms of not getting tricked too easily about some of these things here? Again, it's all about knowing these little rules, because I'm telling you, once we get past this page of notes, we're going to get through some warm-up problems. After that, it's back to back problems. So let's go ahead here, write that down as needed. And now let's get into the last one here, multiplying terms. And so there is a rule for dividing terms. It's literally the opposite of multiplying. And I'm going to save that for a class coming up in early October, where we're going to be working on rules of square roots and rules of powers. So we're going to have a 2-day session here where it's 2 hours each. One of them is going to be all about, multiplying and powers to powers and doing our thing there. And the other one is going to be all about dividing and using square roots. So get ready for that. So multiplying terms, let's get to it. So multiplying terms, what we say here is multiply the numbers. So what I mean by numbers, I mean the coefficients. So let me make sure I'm specific here. Multiply the numbers, the coefficients. All right. The coefficients is what I'm talking about. And the exponents, we will add them only if they have the same letter, same variable. That's the only situation where we can do this rule here. If they have different letters, then you would just keep those things there and that's it. So I'll give you an example of each, so that way we're not confused about it, all right? So example number 1, let's take a look at this. Let's go ahead and say we've got 2x squared, and we're multiplying this with, let's go ahead and say 3x to the power of 11. So let's go ahead and say we're doing something like this here. Hey, how's it going, Des? Welcome in. So the first step was, everybody, true or false, multiply the coefficients, multiply the numbers. Is that what I said? Yes or no? Yes, it is what I said. Multiply those numbers, multiply the coefficients. So over here, the first step we'll take is going to be taking the 2 and the 3, we'll multiply them and we'll get 6. Next, what did we say we would do with the variables? Go ahead and type it out there as quick as you can. What did I say we would do with the variables? What do you mean by add? Add what? Let's be specific here, because we really want to make sure that if we ever forget, we can recall this as we need to. So adding what? Yes, add the exponents. Add the exponents of the same variable. So right over here, right over there. Add the exponents of the same variable. Got to do that, all right? Only if they have the same variable. Only if they have the same variable. So if we check this out over here, are those x's the same variable? Absolutely. And so what we're going to do is we're going to take those exponents and add them together. So we're going to end up having 6x to the power of 2 plus 11, which is the same thing as getting a 6x to the power of what? $13. That's right. 13. Right there. Right there. And so remember, gang, there are rules to each of these operations. Let me go ahead and show you a rule where, or an example of where this wouldn't actually happen. So for example here, let's get another one in. Let's go ahead and say we're doing, let's say we have 5x squared, and we're multiplying this with, let's go ahead and say 7y cubed. So if we're taking a look at something like this here, let's go and try it out here. So everybody, the 5 and the 7, what do we do with those? It's okay, Jasmine. Thanks for letting me know. The 5 and the 7, what do we do with those, gang? Yeah, we would still multiply. We would still multiply those coefficients. We would still multiply that right there. So help me out, everybody. 5 times 7. Quick in the chat box. Go ahead. That's right, 35. That's exactly what we'll get. Now, can we multiply the x squared and the y cubed? Can we do that, everybody? No, exactly. They are not the same variable, so we cannot add those exponents. That's easy does it, right? As long as we have these notes with us, we can practice with them and just really, navigate our way through situations like this, where all that would happen is we would keep the letters as they are, keep the variables as they are. So 35x squared and the y cubed right there. So nothing happens to them. Leave them as is, just attach them as if we're multiplying them, but that's really it. So does that make sense, everybody, in terms of multiplying terms? When it comes to multiplying terms, again, we will add the exponents if they have the same variable. If they don't, just attach them together and we're good. And we're good. That's really what it's going to be about today, guys. Knowing these fundamental rules and applying them accordingly. All right. So with that said, my party people, and that's right, Ryan, always combine like terms where you can. Always, always, always. So with that said, let's go ahead and have some fun here. Let's go ahead and start off by, just giving ourselves a nice little warm up here. Simplify the expression 22j minus 13j. I want to give you guys a chance to try this one out. I think that 45 seconds for this one is sufficient. Use your notes there. Type ready when you're ready. Do not reveal the answer. Do not. Just type ready when you're ready. 45 seconds. Here we go. Simplify the expression. We're looking at 22j minus 13j. This probably should be one of the easier things we do today. And so remember, ask yourself, hey, are these like terms? So step number one, when you're doing polynomials here and you have to like add or subtract or simplify, first step is, hey, look, ask yourself, are these like terms? Everybody, what's the answer to that question? Yeah, the answer is yes. The answer is yes. Check that off right there. Yep, they are like terms. So now what we're going to do is perform the operation. Adding or subtracting, we clearly see here that that's subtracting. So we're going to subtract the 22 and 13, which gives us what, everybody? 22 minus 13 is? That's correct. That's going to be 9. So 22 minus 13, that's going to give us 9. And then we have the j's here. What happens to the j there? What happens? Exactly. That's right, Mario. Our rule says you keep the variable. You keep the variable here. And so boom, it'll be 9j. So remember, so that we can make an intuitive connection here, you're basically saying, hey, I got 22 of these things and I'm taking away 13 of those things. How many of those things do I have left? 9 of them. So it's kind of like saying, hey, I have let's go ahead and say, let's use a phone here. I got 22 phones. I'll take away 13 phones. I have 9 phones. And there it is. That's another way to think about it. So with that said, the answer to this question will be C. It will be C. Right on. So let's go and try another one out here. Let's keep it moving. Let's try this one out. I'm going to give you 45 seconds again. Go ahead. Because again, we're just practicing these rules, these fundamentals, because once we pass the 5th problem, it's going to get interesting. So let's go. So simplify the expression. We've got 14p squared plus 2p squared. So when we check out something like this, same thing we're going to ask ourselves. We got letters involved. We got powers involved. Let's make sure we can look at any new problem with the same lens so we can get the same correct result. So what was the question that I asked? Last question first. What was the first thing I asked in that last question? Because I really want to train y'all on how to handle unfamiliar situations. What was the first thing I asked? I see 4 people there. I'm pretty sure there aren't 4 people here. How many people here? Oh, we got about 100 here. Okay. Come on. Yeah. Are they like terms? That's what we're going to ask here. Are these like terms? And to get like terms, same letters, same exponents. Do we have that? The answer is yes, because we have p over there and we have 2 in both. P squared for both. So yep, we got it. And so what we're going to focus on is combining these like terms by, again, adding those numbers in the front, because it is adding right there. And then we'll get 16. And then we just repeat everything we had over. So the p squared, we just repeat it. So the answer here is 16p squared. Nice and simple problem there. And that's going to give us b. If you pick D, which I saw some people pick, what happened there is you may have thought that we were using multiplication with the variables, but adding the numbers. And that's not how it works. You can't just mix them both like that. There's certain rules, all right? Here, when we're combining like terms, it's all good. It's all good because mistakes are going to happen. So no need to apologize. Mistakes are going to happen. But remember, when they have the same variable and exponent and you're adding, add the numbers in front, keep that train moving. If you're multiplying, it doesn't matter if they have like terms. You will go ahead and add the exponents of the same variable and multiply in the front. And that's it. So again, with more practice, we'll get it. With more practice, we'll get it. No need to apologize. So let's go ahead and try this next one out. This one, we haven't really exactly gone over yet. We have gone over multiplying. We have, but have we gone over distribution? So if you haven't gone over distribution yet, Jose, I got you after this one. If we haven't gone over distribution yet, this is exactly how I would address it. I think, honestly, this is the one thing that I love doing. I love teaching semi-complicated topics in English in a way that just makes sense, as opposed to thinking like you're reading through a textbook. I don't ever want to feel like you guys are learning that way. I want you to learn in plain old English. So when it comes to distribution or the distributive property, here's the one thing I want you to know. What I want you to know is make sure everything on the outside multiplies with everything from the inside. All right. Go ahead and write that down, copy that down, copy that down. All right. Make sure everything from the outside multiplies with everything from the inside. And so here's how we're going to take care of it. I'm going to zoom on in just a little bit here. And here's what's going to happen. What's going to happen is this x is going to multiply with this x. So you can call that, x multiplied by x. And then in the other one, that x is still on the outside. It still hasn't multiplied with the 2. So again, everything on the outside multiplies with everything on the inside. That's all distribution is. A lot of y'all have seen that as, anybody here heard of FOIL, F-O-I-L, for multiplying binomials? Right? You've heard that. Yeah. That stems from this basic idea. Distribution is literally everything from the outside multiplying with everything from the inside. That's all it is. I'll show you an example after this. So here we have x multiplied by x, and then we had x multiplied by 2. So when we check that out, everybody, we're multiplying x multiplied by x. What is the result going to be? What is x multiplied by x? What's that going to give us? Okay, so a lot of y'all are saying x squared. Okay, I got a question though. I got a question. I really do have a question that I think a lot of people might be asking here. Why do we get 2 if there are no numbers up top here? Why do we get 2? Why do we get 2? Right, Christine, we are multiplying. And the rules for multiplying variables says add the exponents. But I don't see any exponents. What's the problem there? Boom, right there. Thank you, Janice. And I think someone said it before. Shadre, that's right. There is a 1 there. There is a 1. Remember, when you don't see an exponent, the exponent is 1. So let's write that down. If you need to, let's go and write that down. So here we go. Let's start that off. So if you don't see an exponent, the exponent is 1. So if you don't see an exponent, the exponent is 1 every single time. All right. Every single time. So that means that 5 is the same thing as 5 to the power of 1. That means that x is the same thing as x to the power of 1. It really, again, if you have like, let's say 7y, that's the same thing as 7y to the power of 1. It's the same thing as all those things there. All right. Got to make sure we understand that because the rule still applies. We're going to add the exponents. 1 plus 1 is 2. And that's where that 2 comes from. That's where it comes from. And so from there, we have 2 multiplied by x. Everybody, what happens there? What happens there? That's right. It's just going to be 2 times x, which is 2x. That's it. Nothing to do there. Nothing to see. Just move right along and you're fine. So we have x squared plus 2x right there. And so that's why the answer for this one will be A. Will be A. So So far, we've talked about combining like terms. We've talked about multiplying. We've talked about distribution. Now we're going to get into basically mixing these ideas and talking about what we discussed earlier. What if there's a negative in front of a parentheses? What do we do then? Let's try this one out. So again, in the red that you see right up there, that's something that you might want to write down for sure. So here's what's happening when you're subtracting or you have a negative in front of a parentheses. The negative gets distributed. And the easy way to think about it, like a lot of people were saying before, because they've been to my classes, is change the signs of everything inside. That's it. Anthony, this is a problem that you might see, man. I got you. So again, when you have a negative in front of the parentheses, don't freak out. Like I'm teaching you what you should do in these situations. Like this is how you can feel empowered and feel confident. When you have a negative in front, distribute the negative to break the parentheses. Long story short, change the signs of everything on the inside. Has anyone here ever heard me say this? Subtracting is the same thing as adding the opposite. Has anyone ever heard me say that? Yeah, exactly. If you've been to my classes, if you've been to my program, I've said this a million times over. Subtracting is the same thing as adding the opposite. So here's what I can do. I can show you this. So subtracting, again, write this out here. Subtracting is the same as adding the opposite. So whenever you see a negative in front of a parentheses, like you shouldn't get into that zone where anxiety takes over. I don't want that to happen. Let me show you the actual way we should be doing this. So adding the opposite. So what I mean by this is adding the opposite. If I look at that negative right there, and I look at the signs of all of the numbers inside, we are going to instead add the opposite. So let me rewrite everything that was there already. I'm just copying everything down right now. Just copying what it is. And so what I'm going to do now is go from minus to adding to plus. And then we can have on the inside here, that positive turns into a negative, correct? That positive 2g to the fourth will turn into a negative 2g to the power of 4. And then here, we are subtracting 5g cubed, and that'll turn into adding 5g cubed. That's what's going to happen here. Again, we are adding the opposite, all right? Adding the opposite. And so once we've got this, here's how we're going to take care of this. There's a plus sign right here. But the thing is, at this point, everybody, is there anything getting in the way here of breaking that parentheses down? Is there anything in the way? I got you, Des. I'm going to bring it back at the end here. Right, so here's the thing. There is really nothing in the way. Like, yeah, there is a 1 there, but when you think about it, 1 multiplied by anything, it's itself, right? And so technically there, yeah, that's not going to affect it. So for those of us that are confused, here's how I want you to think of it. So let me give you the procedure before we get into the actual nitty gritty. Again, right here, the negative gets distributed. Easy way to do it. Easy way to do it right here. Change the signs of everything inside. That's it. Add the opposite. And so what you're doing here, everybody, if I'm subtracting positive and negative, I'm basically going to add negative, positive. Just do the opposite. That's it. That is it. That is it. And so what's going to happen here at the end of the day is you're going to have 5g cubed minus 1. And since you're adding a negative, that's the same thing as subtracting. Same thing as subtracting. So minus 2g to the fourth plus that 5g cubed. So again, all that's happening, if you're subtracting in front of the parentheses, just basically change the sign of everything inside and proceed as normal. Proceed as normal. Essentially, Janice, yep, that is correct. And so Rivka asks, hey, why haven't we messed with the front part of this? So when you think about it, Rivka, there really isn't anything over here with the 5g cubed minus 1. There's nothing in the way of us breaking that parentheses down. There's really nothing in the way because There's no negative there. There's no number besides 1. And so when you think about it, again, nothing really happening. Nothing really happening. Another way you can think about it is, hey, there's a 1 in front of this. Again, there's a 1 in front of every number. But think about it. What's going to happen if I do 1 times 5g cubed? That'll just be 5g cubed. And then when you do 1 multiplied by -1, that's just going to be -1. And so while there is a 1 there, it's not going to change anything about the inside. And so we can just ignore that. There's nothing for us to worry about. Does that make a little more sense? In terms of why that first part there is going to stay the same. Exactly. You're going to have extra work on your scrap paper, Anthony. Exactly. Good point. Joshua, yeah, exactly. Subtracting is the same thing as adding the negative of the number or the opposite. Yeah. Yep. So essentially, if you want to think about it this way, we can just erase all this right here. And you can go straight from that top part right here. And just go ahead and take this that's adding, subtract it. That's being subtracted, add it. That's what happens again when you are subtracting the parentheses in the front. All right, that's what we're doing here. So let's take a look here, everybody. Do we have any like terms that we can combine? That's right, Nelia. Do we have any like terms that we can combine? Call them out. What are they going to be? What are those like terms going to be? What are they going to be? The g cubes. That's right. Anything with a g cubed in front of it or g to the power of 3, that will be considered a like term. And so when we check out the problem, yeah, we got something like that. We definitely do. I see here that we have a 5g cubed, 5g cubed. We can bring those together. And so does anybody here look at this and think, well, they're not right next to each other. Can we still combine them? The answer is yes. The answer is absolutely yes. We can still combine them, even though they're far away. Just make sure to bring the same sign. We have a plus right here. So what we're going to do is we're adding this and this together. Bring the sign with it. Everybody, 5g cubed plus 5g cubed. What's that going to be? What is that going to be? Correct. Yes. That's going to be 10, because again, 5 plus 5 is 10, g to the power of 3. Our rules say that we are not going to add those exponents. We only do that when we're multiplying everything together. So that's not happening. Next, are there any other like terms, everybody? Are there any other like terms? Great point, Christine. Exactly. Because there are no more like terms here, again, we have g cubed, g to the power of 4, and then a regular old number. So that's it. We don't have any more like terms, so everything else just drops. So what we're going to have here, -1 minus 2g to the power of 4. And so in a lot of the problems that you'll see, as you see here, I want you to notice something. The answer choices, they are ordered from greatest to least. We have to, a lot of the times, order the polynomial. And the order goes really easy from high to low on the exponent. 4, 3, and then the rest. 4, 3, 4 is the first one always. So you just order it from high to low. Want to make sure you know that. So we're going to put these exponents here in order. Everybody, what should be up front first? Right, the G4, exactly. But are we going to bring the negative with us, or are we keeping it there? What are we doing? Should we bring the sign with us? That's right, Lizzie. Bring it. We are always bringing it. That's right, everybody. You have to bring the sign of the number. Think about it. When you combine like terms, notice how you bring the sign, right? When you move things around, you bring the sign with it. You bring the sign with it. So we're going to have a negative 2g to the power of 4. Now, even though we don't see a sign here, everybody, what's the sign going to be for that 10? What's the sign? Exactly. It's going to be plus. Exactly. And then the -1. And there we are. Let me not use blue because that's probably horrible there. But there it is. Negative 2g to the power of 4 plus 10g cubed minus 1. And the answer here will be B. So this is the point in the class where I'm going to take a quick moment. I'm going to take a couple questions here. How are we feeling right now, my party people, in terms of going from, hey, I see parentheses, I see a negative in front of it. Where are we in terms of our confidence in knowing that all we have to do when we see a negative there is just change the sign of everything inside? Went from stuck to doable. Nice. Little iffy, Maya. No worries. We're going to get more practice here. So remember to keep that in mind. Negative in parentheses, something I got to work on. Negative in parentheses, I got to work on it. Remember, it's all about getting one day better, one day at a time. With practice, you'll get better for sure. Flip the signs when there's a problem like this. That's right, Boone. Perfect. Hey, Des, remember, stick with it. You got to pay attention. So put your phone down, stick with it. Each problem, ask those questions. Why, man? We got this. So let's get to it. This next one here, we're going to review these notes one more time, and then we are getting to practice. So for each of these practice problems, I am only giving, depending on the problem, a minimum of some of these problems will be 1 minute. The maximum I'll extend it to is about 1:45, depending on the problem, all right? And you'll know which ones they are. So again, between 1 minute and 1:45 is what I'm going to give you. Don't share your answers. What I do expect is that you try your best. We have our notes, use those notes. That way we can go ahead and give ourselves a shot here, because the next step is not using your notes. The step after that is working for speed. So we got to make sure we keep those things in mind. Know that there's levels to this. And so right now it's completely okay to rely on your notes. If you need to ask me a question in the chat box, I got you. I'm here to help you out. But then eventually you do want to work with the expectation that you're not going to be using your notes anymore. But for right now, it's fine. So it's all good, right? I got you. How do we know the plus in front of the 10? Oh, because if you just say, think about it like this. If you just say 5, that's positive 5. If I say I have 5 apples, there are positive 5 apples there, because you're not going to assume that if I say 5 apples, it means you're taking them away. So if you just have a number without a sign in front of it, always positive. Again, if you have a number without a sign, always positive. All right. So with that said, again, let me get that timer ready. We're going to start straight off with this first one here, my party people. Just do your best and we'll keep growing. 3, 2, 1, let's go. We have 1 minute for this one. Let's get started here. Simplify the following expression. I'm not even going to look at the answer choices. Let's just go ahead and ask ourselves our basic questions. Everybody, what's that first question I want you to ask? What's that first question? Right, like terms. Do we have like terms? Everybody, yes or no? What are they? If they are like terms, where are they? What are they? Right, if we look at the v squareds, I got a v squared right here, v squared right there. So what I'm going to do is I'm going to do this. I'm going to grab the 6 right there and a positive 6 again right there. Because again, you're bringing the sign. Remember, bring the sign. Let me just make sure you are aware of that. Bring the sign. Way too important. Super easy to forget. Bring the sign. And so if I have 6 plus 6, what's that going to be, everybody? Help me out, man. Yeah, that's going to give us 12. Exactly. 12 what, though? V squared, V4, V9. What's it going to be? There we go. I got y'all locked in. Yep. V squared. Exactly. Remember that the variable stays the same when you're adding and subtracting like terms. Stays the same. You're good. It's like saying, hey, I got 6 of these V squareds. I got 6 of those V squareds. I got 12 of them now. Next. Up next, we got the 1 and the 8. Notice that's a positive 1 and a positive 8. If I bring a positive 1 and a positive 8 together, we get exactly. And that part was pretty straightforward. I know for the numbers, I know a lot of us are like, yeah, we're good. It's just the variables that sometimes make us a little uneasy. But the thing is, like, they follow the same rules. They follow those same rules. So we got 12v squared plus 9. Boom. What's that answer going to be, everybody? Hit me. That's right. That's right. And so If you're asking, hey, will I get a problem like this on the ASVAB? Yeah, these are on the easier end. These are on the lower end. These are on the straightforward end. Yep, for sure. Later on, we're going to see more difficult problems, and these are going to be like your medium to tough problems. And I do have some challenge questions for y'all toward the end here too. So Stephanie asks, what if they give you a question where you aren't sure to bring the sign or not? So that's the beauty of it though. When you're combining like terms, you always bring the sign. The only thing you got to make sure you watch out for is you can't combine like terms from different parentheses. You got to break the parentheses first, then combine. So one more time, Stephanie, the only situation where you might want to watch out for is parentheses. Make sure to break the parentheses first before you combine like terms. So let me know if that helps you out a little bit. There we go. Let me get Deandra in here. Boom. So let me know if that helps out even a little. So let's go ahead and get to the next one, gang. Here we go, man. Let's have some fun. 3, 2, 1. Next. I'll give you a minute 15 for this one. A minute 15. All righty. So with that said, simplify the following expression. Okay. Everybody, first question is, I'm going to be annoying with it. First question is going to be what? Ask what? Yeah, like terms. Do we have like terms? Exactly. And so everybody, I see 3a to the fourth, a to the power of 3. I got 3's, right? These are like terms, right? 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 Yes. 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 Y'all getting harder to beat. All right, sounds good. Do I give anybody here trust issues? All right, so let's try this out, man. So let's ask ourselves, let's be specific. Be specific with your reasoning, especially you, Felicia. Why are these not like terms? Different exponents. That's right. That's right. So let's go ahead and really zone in here. Remember, we have the same variables, which is great, but we do not have the same exponent. We do not. We do not. Those aren't like terms. It is not going to be 4a to the power of whatever. No, 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 no. Those are not like terms. Let's bring everything else in here. If we take a look, the actual like terms are going to be over here. A to the fourth, a to the fourth. Those are like terms. And when you look at the other way here too, a cubed, a cubed. Those are going to be the like terms. Yeah, no worries, Linda. Again, so like going through this practice is really going to help us really gain that confidence. I got you. I got you. And so with that said, let's focus on one thing at a time here. We got 3a to the power 4. So in purple over here, let me circle that over here. And we have, is it a positive 8a to the power 4? Yes or no? Is it a positive 8a to the power 4? No, 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 no. Exactly. No, it's going to be a negative. We're bringing the minus with it. We're bringing the minus with it. Remember, gang, bring the sign. And one more time here, I'm going to expose that again. Bring the sign. Way too important. Way too important. And so when we bring that sign here, what we're really doing is 3 minus 8. And then we're going to attach that a to the power of 4 in front of it. So everybody, what is 3 minus 8? And let me know if you are a little anxious about dealing with negative numbers. I see a lot of us giving us that -5, which is correct. Tiffany, you a little bit. Anybody else feeling a little, Sandra? Okay. Rivka, Demai, Ryan, I got you. I got y'all for sure. So here's how you want to deal with it. Everybody, subtraction, that's pretty much the same thing as taking the difference, right? Subtraction is like taking a difference, right? We're seeing, hey, how far is this number from this number? Everybody, think about it. How far is 3 from 8? How many numbers away? 3 from 8. What's the difference? Exactly, it's 5. But what's the problem? We're not doing 8 minus 3. We're doing 3 minus 8. We're doing the opposite way. So we're going to get the opposite sign. 3 minus 8 is 5, but negative because it's the other way around. And so it'll be -5. Did that help anybody out at all, helping them understand this? Again, 8 minus 3 would be 5. 3 minus 8, -5. It's literally just looking at it the other way around and then putting a negative in front. So I hope that helps somebody here. Again, there's so many little tips and tricks that we want to practice, and I got plenty of that for you. Again, and I saw someone ask about it earlier. I'll talk about my program and the subscription or whatever at the end of class. So don't worry, just stick to the end. Right now, I just want you to focus on doing your best and learning this. I'll talk about my class. Don't worry about it. So over here in red, we've got positive a cubed, negative 7a cubed. Everybody, what number is in front of that a cubed? Positive 1. That's right. Remember, if you don't see a number, it is always 1. So don't see a number. It's 1. It's 1. If you don't see a number in front of a variable, it is 1. There are one of those variables there. Because like, think about it like this. I could say apple, or I could say 1 apple. Both of those mean the same thing. There's no point in saying that there's one of that thing every single time. It's like meeting up with your friend and being like, hey, I'm going to go hang out with one John today. I'm going to go hang out with John, right? It's a little redundant. It's not really necessary. Not really necessary. And so in English, that same idea translates to this. If I got a cubed, I have one of them there. So I want to make sure people can think about this again in English intuitively and not like, oh, math, you know, I got you. So here we go. We got 1 minus 7. What is that going to give us, everybody? 1 minus 7. What's that going to give us? Negative 6. Remember, everybody, if you think about it the opposite way, 7 minus 1 is 6. But if you do the opposite, 1 minus 7, that's just the opposite sign, negative 6. So we're going to have minus 6 and then bring that variable in the exponent. You leave it the same. So our answer here is going to be negative 5a to the power of 4 minus 6a cubed. And that is answer D. Who's feeling pretty good right now about this? What's up, Tawan? There we go. That's right, Pedro, Demaya, Anthony, Angie. Des, there we go, man. Bringing it back. That's what I like to see, man. That's what I like to see. Ooh, y'all blew up that chat box. Right on. So Zoe, even if you don't understand the signs, mark that down. So dealing with negative numbers, I actually have a video on my YouTube channel that I would love to share with you. It's a 2-hour class that we did on negative numbers. And I can promise you by the end of that class, you're going to be feeling pretty good. So to prove a point, everybody who was here for that negative numbers class, give me a yurt in the chat box if you feel like it helped. And there you go. So again, go ahead and work on it. It's all about getting one day better, one day at a time, Zoe. I got you. I got you. So up next, here we go. 3, 2, 1. All right, here, this problem, 1 minute, 15 seconds. Go. Cool. So here we go. Let's check this out. Simplify this expression. And I already set us up for this. The idea that we're following here is distribution. Okay? Distribution. Everybody, when you're distributing, what operation do you believe is happening there? Addition, subtraction, multiplication, division. Which one is really happening when you are distributing a number or a variable or a term? Correct. Multiplication. Multiplication, exactly. So if you weren't here for this piece of note, one more time, here it is. Again, distribution, multiply everything. Multiply everything on the outside with everything on the inside. Everything on the outside with everything on the inside, all right? That's what it's going to be all about. Multiply everything on the outside with everything on the inside. I know that's chicken scratch. I typically don't write that messy, but yeah, everything on the outside with everything from the inside. And so when you look at what I wrote here and color-coded everything, I hope that this helps you understand this, because the 3n is going to multiply. It's on the outside here, right? The 3n's on the outside. And so the 3n's going to multiply with that n, and it's also going to multiply with the 2. And so there it is. 3n times n in orange, and then 3n times 2 right there in blue. And so boom, with that said, now let's go ahead and get to it. Everybody, 3 times nothing there is just going to be 3, right? Because that's technically going to be a 1 there. That's technically going to be a 1 there. So it's like saying 3 n's times 1 n, 3 times 1 gives you that 3. And then n times n, everybody, what's that going to give us? Is Demaya the only one? Is Felicia the only one? N multiplied by n is going to give us what? Yeah, n squared, n squared, n squared. Because remember, what's the rule for the exponents again, everybody? Chat box, go. When we are multiplying variables, we do what with the exponents if they're the same exponent? That's right. We add them, we add them, we add them, we add them. That's right. And so there's a 1 here. Let me use a different color here. There's a 1 here and a 1 there. And so remember, if there's no exponent, there is a 1 there. And so the rule says add those exponents, and we're going to have 3n to the power of 1 plus 1, which is 2. So 3n squared. So again, we're going to add these. We're going to add those right there. Up next, we got 3n times 2. All we're going to take care of is, again, the numbers here. 3 multiplied by 2. Easiest question of the day. What do we got? That's right. It's going to be 6n. So what we're going to have here as a final answer will be 3n squared plus 6n. 3n squared plus 6n. Is anybody here that was previously, so again, don't answer if you're feeling really good right now. Anybody here that was previously a little confused by distribution? Are we seeing the pieces come together a little bit with this one? Are we feeling a little better about this one? Cool. And even if we're not 100% there, remember that this is all a process. It's all about learning. And when we're thinking about learning, guys, look, think about it like this. You really got to ask yourself, like, where am I right now? Like, what do I understand? You know, whether it's the basic notes, whether it's how to do basic problems, medium, whatever it is. Where am I right now? What do I know? And then you want to ask yourself, well, what is it that I don't know? What step am I really having trouble with? Is it dealing with negative numbers? Oh, is it how to distribute with a parentheses? Is it being timed? Like, really, we have to ask ourselves these honest questions, because that's how we eventually get to grow. All right. So with that, there we are. Answer here is D, 3n squared plus 6n. So Jessica, right there, yeah. If being timed is the problem, and you know you could do it with your notes, boom. Right on, right on. So thanks for being honest there, gang. Oh, yeah. So, this is the cool thing. So thanks for reminding me, Tiff. Thanks for reminding me. This is actually going to be super worth it, everybody. So everybody, distribution, yes or no? One more time. Have you heard about FOIL? F-O-I-L, first, outside, inside, last. Who's heard that before? Whether you know how to do it or not, who's heard of it before? All right, cool. I'm about to blow your minds, guys. Watch this. So let's go ahead and say we're looking at a problem like, x plus 3 times x plus 5. We might have seen something like this once or twice in our lives, right? We might have seen something like this. Now, let me show you the thing here. Everybody, in school, they would teach you FOIL, F-O-I-L. But everybody, what did I say? Type it out in the chat box. I want to see at least 20 people type it out there. What is the rule about distribution? What do I always say here? Go ahead. About distributing. What do I say about distributing? Who has those notes down? Come on. Again, what did I say about distributing? What did I say about distributing? Thank you, Tawan. There it is. Make sure everything on the outside multiplies with everything on the inside. I literally showed you right here, right there. Make sure everything on the outside multiplies with everything on the inside. All right. And so because of that, we need to go. Thank you, Janice. Thank you, Janice. Thank you, Mario. Right on. So this is exactly what you're going to do. Watch this. Super straightforward. I'll just go ahead. I'll make sure that the x multiplies with this x. I also got to make sure that the x multiplies with the 5. I also got to make sure that, okay, well, the x is done because this x already went with the x and the 5. Then I'm going to make sure that the 3 goes with the x and the 3 goes with the 5. So that's the idea. Look, all I did here was make sure that everything from the outside multiplied with everything from the inside. That's it. If I see 2 terms here, the x has to multiply with 2 things. The 3 needs to multiply with 2 things. Multiply everything from the outside with everything from the inside. Now, where FOIL comes in, they teach you FOIL as a way to simplify this. Watch this. Watch me do this. I'm going to say F. Then I'm going to say O. Then I'm going to go, excuse me. FO for outside. Then I'm going to do I for inside. Then I'm going to do L for last. That's how they teach you in class, right? But what do you notice? Oh, F, O, I, L. This is literally everything you got taught, just in a simplified way. I wish they would have taught you again, just make sure everything from the outside multiplies with everything from the inside, because it won't matter how many terms you have. It won't matter if it's 2 and 2 or 3 and 3 or 5 and 5. It won't matter. It won't matter. Another way to do it is with the box method. I love that method too, but I always want to make sure that y'all understand what distribution really is. All it is multiplying everything from the outside with everything from the inside. Does that make a little more sense, everybody? Again, because you have to know the fundamentals, man. Gotta know the fundamentals. Shortcuts are great, but you got to know where those shortcuts come from, because that's how the confidence stays. But if you're just memorizing tips, tricks, and shortcuts, then once the real deal hits and they change a little thing up, you're going to be sitting there like a fish out of water, like, whoa, whoa, whoa. And then you get freaked out and things happen. And we don't want that. So FOIL stands for first, outside, inside, last. First, outside, inside, last. That's really what FOIL stands for. And so with that said, man, let's go ahead. Let's keep moving forward here. Again, distribution, multiply everything from the outside with the inside. Let's get that timer going. 3, 2, 1. Let's go. This one, 1 minute, 15 seconds. All right, let's check it out. Let's check it out. Let's check it out. So we got 6x plus 5x cubed minus 3x cubed. And then we have a minus x. Okay, so let's check out those like terms, man. Starting off with those like terms. Everybody, are 6x and negative x here like terms? Yes, they are. They have the same variable and the same exponent. Yep, they're just x's. Yes, that is correct. They are like terms. What about the 5x cubed and negative 3x cubed? Are those like terms? Sounds good. Let's go ahead and get to it then. So what we're going to take care of, typically what you want to do is you want to take care of the higher exponents first, because you know how at the end you want to put them in order from biggest to smallest. So it might be a good idea just to start off with the bigger exponents and then work your way down. So what we have here, 5x cubed, negative 3x cubed. What I'm going to do here is I'm going to go ahead and use purple. I'm going to say that we got a positive 5x cubed minus 3x cubed. So everybody, 5 minus 3, what's that going to give us? So Malik, great question. You add the exponents when you are multiplying the variables. Notice how here, we're just subtracting them. In purple, we got the 5 minus 3. And so what that's going to give us is going to be 2. And then we keep these the same. Because remember, if you're saying, hey, I got 5 of these Ferraris, I'm taking away 3 Ferraris. I got 2 Ferraris left, the x cubed being Ferrari. So again, you can use a bunch of different things, pineapples, potatoes, strands of hair. I don't know. Doesn't matter to me. Whatever helps you get better at this is really what I'm about. But here we go. 6x minus x. Everybody, what do I always say about that sign in front? What do I always say about that sign? What do we have to make sure we do? Come on, what do we got to make sure we do? When we're combining like terms, what do we do with that sign? Do we bring it with us? Yeah. Yeah, we would bring it with us. Absolutely. Absolutely. I saw a question from Erica here, but I thought we would add the like terms one first. Yeah, so here's the thing, Erica. I got you. So you can add the like terms in whatever order you want. So here, I just chose to start off with the cubes, and then I work with the regular x's. You could have started with the regular x's and then done the cubes. Either way, you still get the same answer. Either way, doesn't matter. And so it's just really about ordering them. So if I want to bring that sign over, so let's go and get back to it here. It's a minus. So we have 6x minus one of those x's. If I take away one of those x's, I'm left with, right, 5 x's right there. So is that correct? Is that correct? Took y'all a second. Nah, it's not correct. What did I do wrong, everybody? What did I do wrong on purpose here? What did I do? Yeah, I put a negative there on purpose. It's not going to be a negative. It's going to be a plus. Plus, plus, plus. Got to make sure y'all paying attention. Got to make sure y'all paying attention. Yeah, so Tiffany, as a rule of thumb, yeah, just start with the higher one. Again, it's not going to affect the outcome of the problem. At the end, if you didn't do it at first, at the end, you'll just have to swap some terms around. That's it. Because if you look here, again, just look at the answer choices. They all start off with the x cubed, then they move down to the x, right? So I really want you to see that there, so that way it's not like, oh man, I got to do this all the time. Like, no, it's just a general rule of thumb, because at the end, you're going to swap things back. And so the answer here will be B. Right there. So just a rule of thumb. So Maya, how is it a positive? Yeah, I got you. So Erica, okay, so two things here. One, Erica, these are not like terms. A like term, a pair of like terms, again, is the same variable and the same exponent, the same power. So although we do have x's, notice how one of them is just x to the power of 1, just x there. And then this one over here is a 3. And so because of that, no, those are not like terms. And so then for Maya, I got you. And then for Maya, how is it positive? So remember what you're doing here, you're subtracting. If I got positive 5 minus 3, that's positive 2. If I got 6 of something and I take away one of that something, so 6 minus 1, that's a positive 5. Yeah. I put the negative there to see who was paying attention there, but that's what's going to be happening there. So let me know if that makes sense, Maya. I got you. So yeah, again, 6x minus x. I got y'all. So 6x minus x. That's like saying 6 minus 1 of those x's. Yeah, they are like terms. They are like terms. And so you can treat this. Let me go ahead and type there. We can treat it like this. Everybody, what do I always say? What number is in front of a variable that doesn't have a number in front of it? A 1, right? Absolutely. So if I put a 1 right there, so think about it now like this. If I have 6 x's and I take away 1 x's, how many x's do I have left? Right, it's going to be 5 of them. It's going to be 5 of those x's. And so that's why it's going to be just 5x left. That's why it's going to be positive 5x. Yeah, because it's like saying, hey, I got 6 pineapples. Take away one of the pineapples. I got positive 5 left. It's not 1 minus 6. It's 6 minus 5. So I do want to move on here from that. But again, if negatives and positives are getting you tripped up, again, I do invite you to watch that session that I did on negative numbers. Great session. I will email that out to everybody probably tomorrow. So up next, here we go, my party people. 3, 2, 1. Let's hit it. This one giving you the full 2 minutes here. And I'm going to give you all some hints in a few moments, but I want you to try to start off this on your own, okay? Try to start this one on your own. I will come in a second to give you hints. Here we go. So let's go and zoom in here. Let's just take it from the top. So what we have here is, okay, this in parentheses minus that in parentheses. So remember, everybody, when it comes to parentheses, what you're going to be doing is distributing. That's what's going to be happening. So everybody, what is in front of this parentheses over here on the left side? What do we see in front of that parentheses? Right, there's just an imaginary 1 there. Remember, when you're distributing, you're multiplying. So if there's just a 1 there, everybody, if there's just a 1 right there, multiplying by 1 doesn't affect it, right? I could do 10 times 1, 10. I could do 1,000,000 times 1, 1,000,000. I could do 57 times 1, 57, right? It's the same thing. So this parentheses over here, you can just break it apart. There's nothing stopping you from breaking it apart here, at least. Do we see that, everybody? Yes or no? There is nothing stopping me from breaking this parentheses down. Yes or no? Do we see that? Cool. There's nothing in the way. Nothing. Now, over here on the right side, there is something in the way. There's a negative in the way. Now, if you took the notes down earlier that I had you take in the beginning of class, it was this. To handle a negative in front of the parentheses, all you want to do is just change the sign of everything inside. That's what distributing the negative looks like. Just change the sign of everything inside. And so let me ask you this, everybody, nice and slow here, nice and slow. This 2k cubed, what is the sign? Again, I highlighted the whole thing in green. Inside of the parentheses, what is the sign of that 2k cubed? Yeah, we should all be saying positive here. We should all be saying positive. That negative is on the outside of the parentheses. Notice that right here. Here's the parentheses. Here's the parentheses. So we are looking at the 2k cubed on the inside of the parentheses. That sign is positive, everybody. The negative is what we're distributing, but the 2k cubed itself right now, it is positive. And so what are we going to do with that 2k cubed positive? We'll change it to 2k cubed negative. So again, that was step 1. Just change the sign of everything inside. Positive turns to negative. What's going to happen with this negative, everybody? This negative is going to turn into a positive, exactly. That negative k squared will be a positive k squared. And so that's really the idea, my party people. I want to make sure that we're taking this one step at a time. Tiff, I got you. Let me go ahead and give you the opportunity to unmute yourself. Go ahead, Tiff.
So when you change the 2k cubed, you leave that minus alone?
So that it basically just disappears because you apply it, you're distributing it. So like, let's go ahead and say we're looking at a problem where we did this. So when we distributed that 3n, notice that the 3n is gone now. We actually applied it. And so we don't have to, write it again like this. It's not like we're going to write it again like that. No, it got applied already. And so it disappears just like it does right here. That negative right there got applied. Mm-hmm. So this is the result once it got applied.
Okay, thank you.
Yeah, I got you. So with that said, my party people, what's left to do now? Now that we've gotten rid of our parentheses, and great question, Tiffany. But now that we've gotten rid of the parentheses, Janice, exactly, you got this down right now, Janice. Yep, like terms, combine those like terms. Let's go ahead and mark our duties here and make sure we take care of it the correct and proper way. So let's go ahead and, for the sake of showing you that it's okay to tackle any one of them first, I'm going to do the squared first and then the cube. All right, the power of 2, then the power of 3. So here I got 4k squared, positive k squared. Everybody, if I combine 4 of those k squareds with just one of those k squareds there, if I combine them, what do I have now? Similarly, you can think about it as I got 5 pineapples and I'm adding another pineapple. Or I got 4 pineapples, I'm adding another pineapple. I'm going to have 5 pineapples, exactly. 5, and then the pineapples is just k squared right there. Remember, we do not modify the exponent when we're adding. We do not. We do not. Now, next, we're looking at minus ak cubed minus 2k cubed. Okay, so again, any of us here that are thinking about hey, negatives, I'm not quite fond of, not the best thing for me. I got you. Think of it like this. Everybody, if I owe somebody $8 and I owe somebody else $2, how much money do I owe in total? Right? I owe 10. Is that 10 going to be a positive or a negative though? It's got to be a negative. Yeah, it's got to be a negative. It's like saying, hey, if I spent $8 and spent $2 more, those being negatives, I spent $10. So negative 10. And so we'll say negative 10K cubed. And remember, if this is something that's giving you a little bit of anxiety dealing with negatives, we got to make sure we write that down. Dealing with negative numbers, I got to work on it. Check. Boom. So here we go. Now that we're here, let's take a look at the answers. Notice how all of the answers here start with the cubes first, then the squares. Hey, easy does it. All you got to do is bring them around and bring the signs. So I'm going to bring the negative 10 cubed up around. And that positive 5K squared right here. Again, there's no sign on it, so it will be a positive. When you are, again, if it's just a number there, it is a positive. And that's what makes the correct answer C. So let's go ahead and see here some questions. Thanks, Vladimir, for that. Appreciate that. Got a direct message here. So why did we not mess with the first part again? This gets me over time. Maybe I'm just overthinking it. So I got you. So again, the idea was, hey, look, there's nothing here, so you can break the parentheses. Nothing there. Break the parentheses up. Or just lose the parentheses. So again, you can remove it because there's nothing there. That's it. You can remove it because there's nothing there. And Erica, why didn't we subtract the 8 and the 2? That's why I want you to watch the negative numbers video that I put up on YouTube already. When you are already negative and you're taking away, you're getting more negative. So again, if I'm already back 8, negative 8, and I take away 2 more, that's taking away a total of 10, negative 10. So again, it's one of those things where we have to definitely practice. And that's going to be for a separate class. I got y'all. So up next, here we go, man. 3, 2, 1, let's hit it. All right, cool. So let's go and check it out, my party people. Simplify the following expression. Now, everybody, I know I already wrote it down, but I'm going to move my screen away so you don't see it. Everybody, what operation is happening when we are distributing? What operation is happening when we are distributing? Multiplication. Yep. That is correct. So let's go ahead and move forward the right way here. We're going to multiply the 5x squared with the 5x in blue here. Then we're going to multiply the 5x squared with the 4. So with that said, let's take care of business. So here we go in blue, 5x squared multiplied by 5x. So when we take care of stuff here, remember with the numbers, we just multiply them. 5 times 5, everybody hit me. Correct, 25, exactly. And then with those exponents, what are we going to do here? With an x squared and an x, we are going to have x to the power of 3. We are going to add those exponents. Remember, there is a 1 here. There is a 1 here. If you don't see an exponent, it's one of those. It's just one of those. And so 2 plus 1 does give us 3, 25x cubed. Then up next in green over here, we're going to have, again, 5x squared times 4. And so from there, well, there's no other variable to mix with the x squared, so it'll just be x squared there. And then when dealing with the regular numbers, remember, we just multiply it. 5 times 4, hit me, everybody. 5 times 4 gives me that. Exactly. It's going to give us 20. 5 times 4 is 20. So we're going to have 25x cubed plus 20x squared. Booyah right there. And that's what's going to give us answer choice C. Right on, Linda. Right on, right on. So with that said, we're going to move into this next one here. Let me see here. We're going to move into this next one. Before I do, just got to mention, I got a couple of people asking about the study guide coming out this Friday. Remember, if you are in the all access pass, if you're in my program, my official study guide is going to be coming out on Friday. Remember that document is pretty much just going to have every single subject for the math and the math knowledge and the arithmetic reasoning, all of it lined up for you, all of the lessons for each specific lesson. So like percents, you'll have the recordings that you can watch, practice problems, and any additional things that you can use like flashcards or worksheets that I'm going to be including. So it's going to do that for literally every single math topic. It's coming out on Friday. I will email that to everybody. I got you. So yeah, eventually it's going to include word knowledge, paragraph comprehension, general science. And one more time as a reminder, if you are in the program, general science just came out last Friday. I put it automatically into everybody's accounts. So just check to make sure that you have it. So here we go, my party people. Next question, 3, 2, 1. Now I'm going to give you 45 seconds for this one. Go. Right on. All right, so let's check it out, gang. Let's go. So simplify the following expression. Everybody, what's the one word you can use to describe what is happening right here? What is the one word that you can use to describe what will happen? What idea are we working off of right here? Ooh, that is correct. That is correct. Starts with a D. It is distribute. Distribution. That is correct. That is correct. That is correct. Yeah, that's for sure. FOIL is a form of distribution when you have a 2 and 2. This is a 1 and 2. You got 1 on the outside, 2 on the inside. And so what's happening is we're going to go ahead and take the 6, make sure that it multiplies with that 5a, but also make sure it multiplies with that -4. Again, that's what the distribution will look like. And so because of that, let's take care of business. Let's go. So we're going to have 6 multiplied by 5a. Everybody, 6 multiplied by 5 is, hit me, 30. And because there's no variable on the 6, it's just going to stay 30a. Then over here in green, we got, 6 multiplied by -4. So everybody, what's the sign going to be? Positive or negative? It's going to be negative. It's going to be subtracting. Yep. Because what we have here, everybody, is a +6 and a -4. The rules are if you are multiplying opposite signs, always negative. And then 6 times 4 is 24. And that's it right there. 30a minus 24 gives us an easy peasy one here. D. And there it is. Yep, I'll list them out very briefly here. I got you. If we do a positive times a positive, positive. Negative times a negative, that's positive. Again, if they're the same signs, always positive. If they're opposite signs, negative. All right, that's the rule. Again, same signs, multiplying or dividing, always going to be positive. Opposite signs, multiplying or dividing, always going to be negative. So take a quick picture of that. 3, 2, 1. Oh, Malik, I will take your question. Go ahead. What's going on?
You hear me?
Yep, I got you.
All right, so a few questions back, it was like we was adding negatives. So if we add the negative, it's going to be a negative. If we multiply the negative, it's going to be a positive.
Correct. Yep.
Okay, got you.
Correct. Yeah, because when you're adding negatives, you're just getting more negative.
Right.
So it's like saying, hey, if I spend money and I spend more money, I'm gonna be in the hole. I'm gonna be negative, right?
Right.
But if I gain money and I gain money, positive, more positive. So it's about really understanding those rules for dealing with signs of numbers and the different operations. And that's why I posted that video on YouTube for sure. All right, so here we go. Next, this one, giving you the full 2 minutes. Let's go. All right, let's check it out here. So remember, guys, when we're dealing with distributive property, especially with negatives, the trick for negatives to make life easy, all you have to do to break that parentheses up is just change the sign of everything inside. So before I even begin, when we're dealing with this one over here, so this parentheses over here, is there anything that's stopping us from just erasing those parentheses? Is there anything stopping us? No, there's nothing stopping us. Like there's nothing in front of it. Again, there's nothing in front of it. You can just rewrite it, no problem. 4 plus 3x squared. Now, here's the thing on the other end, though. On the other end, we have a negative in front of here. So remember how I said that if there's something on the outside, you multiply with everything on the inside? So what happens really is this. This is really what's happening. And when you're multiplying by a negative, all you do is change the sign. So to break this up, hey, just change the sign of everything inside. Everybody, that is currently a positive 1. So over here, we're gonna write what? -1. Exactly. We're gonna go ahead and write -1 over here. Then over here, that was a positive 7x squared. What are we gonna write now? -7x squared. Exactly. We are just simply going to follow that rule and understand that multiplying by a negative means changing the sign. Now, here we are. Let's go ahead and gather our information here. Do we have like terms? Yes or no? Quick. Do we have like terms? We absolutely do. Absolutely, absolutely. So the first set of like terms here, we have a 4 and a -1. Remember, bring the sign with you. Bring the sign with you. So if I have a 4 and a -1, that combines to get what? Correct. That combines to get 3. Then let's just take a look at what we have left. We're going to have plus 3x squared and minus 7x squared. It means a better color there. Probably want to go ahead and use. Whatever. I'll use blue. So a plus 3x squared and a minus 7x squared. I'll zoom in a little bit, make it a little more obvious there. So minus 7x squared. There we go. So taking care of that, remember everybody, think about subtraction as taking the difference. So if it was 3 minus 7, think about it as 7 minus 3, but the opposite. So 7 minus 3, that's 4. Opposite of 4, -4. Again, yeah, exactly. So the rule for subtraction, as I said in my previous class, was if you're subtracting, subtract the numbers, keep the sign of the bigger number. So 3 and 7, 7 minus 3 is 4, but the 7 was bigger, the 7 was negative, so that's a -4. So boom. So with that, there we have it. And we're going to have a minus 4x squared. And so with that said, my party people, what we got now? Well, when you look at your answer choices again, one of them is actually in the opposite order, but this is the correct answer over here. D is the correct answer, simply because when you move that to the front, and then you just move this right to the back, that's what you have. That's what you have right there. So long story short, yes or no, does that make sense? Yes or no? Hey, right on, Tiff. There we go, man. Again, it's those little bits of progress that we're looking for. You know, we're not trying to hit a home run every single problem. It's always about, hey, what was I stuck on? Okay, what am I really trying to pay attention to get a little better, a little better? And if you keep that mentality up, eventually, boom, the big thing takes care of itself. You have a good understanding of the whole topic. But you have to ask those little questions. 3, 2, 1, let's go. All right, so quick, yes or no, is this the easiest problem you've seen all day? Got some no's, got some yeses. Now, for those of us that are maybe potentially saying, yeah, maybe, or it is the easiest one, what makes this easy for you? Why is this one easier than the other ones? Like, we still have parentheses, but why is this one easier? Exactly. It's all positive. Everybody, this is all positive. This is all positive. Think about it like this. Look, there's no negative. There's no negative. When you look at this first parentheses over here, everybody, is there anything stopping us? Yes or no? Is there anything stopping us? No, this is simply going to be 6x squared plus 5x to the power 4. Over here, that's just plus. Is there anything stopping us from breaking that parentheses apart? It's all positive. Yeah, there's nothing stopping us here. There's nothing stopping us here. That's just a 1. And remember, if there's a 1 in front of it, nothing's happening. It's just the same thing there. And so you can actually rewrite all of this as right there. Just break the parentheses apart. There's nothing stopping us, absolutely nothing in the way. If there was a negative or a 2, 3, 4, 5, whatever, yeah, maybe we have to think about it. But here, it's just adding whatever's in the parentheses. So I'm just going to add whatever's in the parentheses, and that's it. And that's it. And so now all I have to do here, combine like terms and have a good day, and we're good. So I got 5x to the fourth, 4x to the fourth. Everybody, 5x to the fourth plus 4x to the fourth gives me what? Be specific, Ryan. 9 what? 9 what? 9 what, Joshua? 9 what, Demaya? 9x to the power of 4. That is going to be correct. Then up next, we got 6x squared, 3x squared. Same variable, same exponent. These are like terms. Everybody, what's that going to be? 9x to the power of 2. There we go. Booyah. That's it. That is it. Our answer here is going to be A, and we're done. And that is it. And that is it. So that's what I meant when I said, like, this is probably going to, feel like an easier problem because we're not dealing with that negative, And so what I want to do here, I'm going to give us one last problem to do. And then I'm going to wrap things up. Again, if you were buzzing about the all access pass, I got you with the discount. Don't worry. So 3, 2, 1. Let's dive on into this last one, gang. Let's go ahead and finish off the right way. Go. Go, go, go. I'll give you the full minute 45 here. So starting off here, what we did first was, again, we had that negative in front of that parentheses. So make everything the opposite. Positive 7b squared changes to negative 7b squared. A positive 8b to the power of 4, negative 8b to the power of 4. So that first step, very standard, very fundamental. Boom. But from there, now we got to take care of the combining like terms, which deals with some negative numbers that we might not be too fond of, right? So if we check everything out, let's go ahead and take things one step at a time. So we have a negative 3b squared and a negative 7b squared. So if I'm checking both of those out real quick initially, everybody, what is that essentially saying? We're essentially saying we have, if I go back 3 and then I go back 7, where am I at, everybody? Right. I am at negative 10. If I take away 3, then take away 7, that is essentially saying 3 steps back plus 7 steps back is 10, but steps back negative. And so what we have there is a negative 10b squared. That's what results. Now over here, we got our 8b to the power of 4 that's negative, and a positive 6b to the power of 4. So what this is over here is this is 6 minus 8. Remember, when you're taking a difference, just subtract the numbers and keep the sign of the bigger number. So 6 and 8, that's a difference of 2. 6 to 8 is 2. But because the 8 is bigger, it's negative 2. So you can write that as negative 2 b to the power of 4. Or you can just rearrange them, put this in the front, and you have negative 2b to the power of 4 minus 10b squared. Just like that. And that's why A is indeed that answer. A is indeed that answer.